Good morning, everyone. This is Sangeeta, working as assistant professor in our department. Today, we're going to discuss about problem solving techniques and introduction about looping and control statements in Python programming. As we all know that before solving any problem in the computer, we must have a idea about how to solve the problem first. We cannot directly enter a code for solving that problem. So we must have an idea what are the requirements that are needed to solve the problem we must think before starting. So these things are comes under the concept of problem solving technique. There are three different problems and techniques these we do. Yeah, like algorithm, sugar code, and the flowchart. These three ways are there to write the problem statements. So here, first we're going to discuss about the algorithm. Algorithm means it's nothing, it's the step-by-step process of solving the problem. So the algorithm have written by using the normal English. So the problem statements have follows an order. These orders are executed one by one. So the algorithm should have concept of solving that problem. This should yield a solution for the given problem. So this is not created independent for any program, independent of underlying languages. So it can be implemented more than one programming language. So any programming language, we must do algorithm. So algorithm, how we can write it? So there is no well-defined standard certain. It depends upon the problem statements, and we can write a algorithm. So have some basic constructs with addition, making statements, looking statements. Those things also will include in that algorithm. Normally, the problem can be solved by three ways. In some applications, have a sequential execution. So if the program have 100 lines of code, each line will be executed one by one in order. So this kind of statement is sequential execution. Some sort of applications will depend upon the certain part of the code only gets executed. So based on the condition satisfied, the particular part of the code only executed. The remaining part will be skipped. So this kind of statement execution is called the selection-based execution. Now we can say it's a decision-based execution. Another kind of thing, if the same particular type the code like execute, we need to execute many times. In that time, the same code will be executed repeatedly. So this kind of situation called as repetition or recursive or iterative one. Iterative. So these three type of execution will normally do. So here, based on type of the application, we can choose either looping or decision-making statements in our code. Example, so if we want to add two numbers, if they're asking us to write the algorithm, we can write by using normal English as like our regular language. So start and declare the three variables of getting the values of A and B. Then after that, add the values of A and B and store the values to the C, then print the C. This is the algorithm. So before solving directly, we must have a practice of writing algorithm. This will help us to get the optimum result. We can also write alternative for this algorithm. Start and get the value of AB, then say J plus B and this place is stop. So anyway, based upon these define, this will have steps. Then in this, what are the characteristics of good algorithm? Algorithm is a step-by-step process, right? So it should have a start and also end. This is also the character. And the algorithm should yield the result. That is the third one. Third one, algorithm should be clear and precise. And another one, we can say the algorithm should be optimized. So number of algorithms, number of steps in algorithm should be minimized, optimized one. And when we call the algorithms good algorithm, so it required minimum time and maximum efficient value, efficient result gives means we can say that algorithm is good one. Okay, this is one way. Then after that, we're going to discuss about flowchart. Flowchart is nothing. After writing an algorithm, we can easily convert the algorithm into flowchart. So flowchart is graphical representation of algorithm is called flowchart. So here, the best standard shapes are there. With the help of the shapes, we can use the shapes in for representing diagram. So each shape have a special meaning. For example, for starting and ending of process, we can use shape oval and parallelogram shape for representing input output, and rectangle shape for calculation, diamond shape for the decision making selection structures. This is an example, like start, front, end. So we can use like this. The shape shows standardized worldwide accepted shapes. This is an example for adding two values. Okay. Then next, other different shapes. Then in the starting and end, will represent a start or endpoint. An arrow shows the blue lines, input output parallelogram, and process shape is a rectangle shape, and diamonds for decision making. So indicate the decision. We have two outlines. One is if the condition is true, the true path will get executed. If conditions fail, the else path will get executed. Another shapes also available. So the delay shape will be like D shape, then hexagon shape is for preparation, and this circle shape for connector, then arrow mark. So there are different flow lines, then display shape, then manual input like this. So several disk storage will be indicated like this. So there will several shapes are there, and usually we will use those primary shapes for representing in a flow chart. So the flow chart also should have the following one thing. Once we have drawn a flow chart, we cannot able to modify it because it's a diagram. So once you are writing an algorithm, we must clear on the execution logic. So and also the flowchart size is also the small optimized one. If it is larger, we cannot able to draw it. And more number of connectors we are using means that to make a complexity. So these things should be avoided while drawing in flowchart. Next class we will have Python Indian topic. Thank you.